So I'll begin with the demonstration of our pen testing tool, which is SQLMap. This is a group effort by Mayank Shetty, Krishna Shetty and Nishant Rajadhyaksha. So then let me begin with the introduction. SQL injection is a type of vulnerability that can occur in web applications that use a backend database. It happens when a malicious user is able to inject SQL code into an input field, such as a search bar, that is not properly sanitized by the application. This can allow the attacker to access sensitive information in the database, modify data, or even take control of the entire database server. SQLMap is an open source penetration testing tool designed to automate the process of detecting and exploiting SQL injection vulnerabilities. It uses a powerful detection engine to scan web applications for potential SQL injection flaws, and then tries to exploit them to gain access to the underlying database. SQLMap provides a range of features that makes it a popular tool amongst penetration testers. For example, it can perform database fingerprinting, which involves identifying the type and version of the database software that is running on the server. This information can be useful for targeting specific exploits that are known to work with certain versions of the database. SQLMap can also fetch data from the database, allowing the tester to access sensitive information that might be stored there. Additionally, it can access the underlying file system and execute commands on the operating system via out-of-band connections. This can allow the tester to take complete control of the database server. Overall, SQLMap is a powerful tool that can be used to test the security of web applications and databases, and to identify and exploit vulnerabilities. However, it should only be used for legitimate penetration testing purposes and with the permission of the system's owner. Now, I'll let Mayank continue with the features.
Features of SQLMap. SQLMap can test the security of various database management systems such as MySQL, Oracle, PostgreSQL, and Microsoft SQL Server, among others. It can detect and exploit 6 different types of SQL injection techniques. These techniques are ways that attackers try to inject malicious code into web applications input fields. The 6 techniques are Boolean-based blind, time-based blind, error-based, union query-based, stack queries, and out-of-band. It can connect directly to the database without needing to use an SQL injection, and can enumerate users, password hashes, privileges, and more. It can automatically recognize password hash formats and support cracking them using a dictionary-based attack. It can search for specific database names, tables, or columns, and can dump entire database tables or specific columns as needed. This feature allows security professionals to extract data from the database for analysis and to identify vulnerabilities that could be exploited. It can download and upload files from the underlying file system and execute arbitrary commands on the operating system. SQLMap supports establishing an out-of-band connection between the attacker's machine and the database server, which can be used to execute commands or even escalate the attacker's privileges. This feature is particularly dangerous because it allows attackers to bypass security controls and gain access to the database server. Overall, SQLMap is a powerful tool for identifying and exploiting security vulnerabilities in databases, but should only be used for legitimate security testing purposes. Now, Krishna will explain the demonstration of SQLMap tool.
Thank you, Mayank. I am Krishna and I will be moving forward with the demonstration of SQLMap. As said earlier, SQLMap is an open source penetration testing tool that automates the process of detecting and exploiting SQL injection vulnerabilities in web applications. So let us begin. So the first command that we have is python sqlmap.py -u, then we have a URL, batch, banner. So here this is the command python sqlmap.py starts the SQLMap tool using the Python interpreter. Now the option U specifies the URL of the target website or web application. In this case, the target URL is Debian dev. This URL is the target of the SQL injection attack. The option batch runs SQLMap in a non-interactive mode. This means that the SQLMap will not prompt the user for input during the scan. Also, the option banner displays the SQLMap banner, which as you can see here, which is a brief message that shows the SQLMap version and other information. Overall, this command is running SQLMap with the specified options and arguments to scan a specified URL for SQL injection vulnerabilities. Okay. So the next command, we'll be modifying the banner option with password. So this command, as you can see, is similar to the previous one, but with an additional option of password. This option instructs SQLMap to attempt to retrieve usernames and password from the target website's database. The option password instructs SQLMap to attempt to retrieve usernames and password from the target website's database. Overall, this command is running SQLMap with the specified options and arguments to scan the specified URL for SQL injection vulnerabilities and to attempt to retrieve username and password from the website's database. So here it is scanning. Okay. So the next command that we have is with the additional option of I skipped over it. Is with the additional option of DBS. So this option instructs SQLMap to retrieve the names of the databases available on the target website's database management system. The option DBS instructs SQLMap to retrieve the names of the databases available on the target website's database management system. So you can see here we have 5 databases available. So moving forward, we'll be going on with the TestDB. So we are changing the options now to tables and TestDB. So the option tables instructs SQLMap to retrieve the names of the tables specified within the specified database. And the database which was specified was TestDB in this case. The option D, TestDB, specifies the name of the database to target. So the next command that we have is dump T users. So the option T user specifies the name of the table to target. In this case, the table is users. The option D testdb specifies the name of the database to target. In this case, the database is testdb. Overall, this command is running SQLMap with the specified options and arguments to scan the specified URL for SQL injection vulnerabilities and to dump the contents of the users table within the testdb database on the website's database management system. So the next command that we have is OS shell. This command is attempting to obtain an operating system shell on the target server. The option OS shell instructs SQLMap to attempt to obtain an operating system shell on the target server. So now we have successfully entered the OS shell of the server. Now we are running the pwd command, and as you know, pwd command is used in Unix-based operating systems such as Linux and Mac OS to display the current working directory. That is the directory that the user is currently in. It stands for print working directory. So in this case, when you run the pwd command, it prints the absolute path of the current directory to the terminal, allowing us to see exactly where we are in the file system hierarchy. This command can be useful when navigating and working with files and directories in the terminal. So the next command that we'll be typing out is whoami. Whoami is also a Unix-based operating system command. And when you run the whoami command, it returns the username associated with the current user's terminal session. Now, after this command, we'll be going with the ls /. So the ls command stands for list and is used to display the files and directories within a specified directory. In this case, the / after ls specifies the root directory of the file system. So when we run the ls / command, it will display the names of all the files and directories in the root directory. This can be a useful way to get an overview of the file system hierarchy and see what files and directories are present in the root directory. So finally, the final command that we'll be trying out is cat /etc/ password. So this command is used to display the contents of the file to the terminal, and the /etc/ password is a system file that contains the information about the user accounts on the system. So when you run the cat command, the contents of the password files are printed to the terminal, as you can see. Each line of the file represents information about a user account, including the username, user ID, home directory, and the default shell. So in this way, we were able to perform penetrating actions. Thank you.